All right, hello and welcome. This is a Space Audits short where I'm going to take segments of information from a larger presentation that I did, condense them into small chunks, and distribute the information accordingly. So this information is going to be in regards to how they say a photon propagate or how light propagates through the vacuum of space by means of the so-called wave particle duality, which they describe mathematically. Um, in terms of giving physicality to the photon to allow it to propagate through a vacuum. Because if you recall back to classical wave mechanics, the way that wave propagation was thought to exist is that it's an excitation in a background medium. For example, if you take, before we get to the photon here, let's do classical wave mechanics. So, in the case of a car blaring its horn while it's traveling towards you, uh, the waves are compressed, so you hear a high pitch frequency because there's more excitation in the medium happening at a rapid rate, and that's what's causing you to hear that high pitch honk, right? So, um, to put that into perspective, the mechanism of propagation for the sound wave is a vibration within the background, within the medium of oxygen molecules and water vapor. And then as the car goes past you, the waves aren't compressed and they're more spread out, so there's less excitation in the background medium. So that's when you get that low pitch, right? So to go from high to low, you have a facilitation of energy being exchanged by a background medium um, that's already there, right? So keep in mind the background medium is already there, and this wave is propagating through it. As Witz likes to say, I can I can hand you I can hand you my wave. I can wave my hand, but I can't hand you a wave, right? So that's kind of what that's implying, and that's how they applied that acoustic understanding to classical wave mechanics, and that's how they understood light to propagate. That's where the ether came from, an excitation within the ether. So when we get to let's discuss luminosity for a second and illumination. So here we have a ferrocell over a neodymium or whatever it's called magnet. And what's happening here is this LED ring light, is illuminating the inside of the ferrocell, and you can see that there's red shift in the light and blue shift in the light, and then you can see the holographic image of the toroidal field of the magnet. So in the dual wave particle duality of light model, what the explanation of what's happening here is that little tiny particles or massless particles of photons are pinging back and forth, traveling along straight lines and somehow producing this effect, right? But what I think is happening is that the LED ring light is producing a frequency, and that frequency is causing an excitation in the background medium, and that background medium being the luminiferous ether, and the excitation being it's causing it to oscillate the ether. That oscillation is producing the visible light spectrum that we see, and the rate in which the oscillation is occurring produces the spectrum of light that you'll visually see. And the magnetic field is retarding the frequency that's being produced by the LED lights. So the oscillation that's happening with or against the magnetic field is either increasing the speed of the oscillation or decreasing it, affecting the visual spectrum that we see. So this is a physical mechanism facilitating an energy exchange. Again, demonstrating the classical wave effect, right? So keep in mind if you try to put space time or a gravitational field, excuse me, under the ferrocell, you're not going to get any redshift or any interaction, right? That's because those things are mathematical concepts and have never been shown to manipulate light or to cause anything like gravitational lensing or be able to cause gravitational redshift or anything like that. So we'll go back to the photon now and why that's completely bunk. So the photon here, these are all wave equations. First of all, E equals hv. This is E. This is energy equals Planck's constant times frequency. So the amount of times the wave oscillates in a second, and then the Planck's constant would kind of be like the wavefronts of how many times it oscillates per second. It's kind of what's going on there. So these equations are wave equations, obviously. Now, when we get to these two, they're describing the energy of the photon and the frequency of the photon, right? So the wave mechanics of the photon. Now, when we get to this equation, P equals H lambda equals whatever that H is, and then K. What they're doing here is they're redefining what momentum is so they can describe how the photon propagates. Now let's take a moment to look at the classical way motion is or momentum is described. P equals m times v, and this is saying P equals mass times velocity. So in the case of a photon, that would be saying 0 times the speed of light, which is 299,792,458 meters per second. So you timesing that by 0, that's not going to work out. That's not going to do anything. So what they had to do was redefine momentum, because remember, part of having momentum is that you have mass. So to propagate through the vacuum, you have to have mass. You have to be a physical thing, but that doesn't exist. So what they do here is they derive the physicality of the photon by saying that the energy of the photon itself is what allows it to propagate through space-time. And they do this here by describing lambda being the wavelength and then times k being the wave vector. So they're basically just describing the energy of a wave and then saying this wave has the physical properties even though it doesn't have any mass. But because we've redefined how we describe mass, this is what allows the photon to propagate. So there is no wave particle duality. There is no traveling of a photon. And to further break that down, we're going to take a look at an analysis by Dr. Julian Brooks-Morenstein on a paper called a frequency-based theory of catalyst, page 11, where they go over this problem with this equation here. She has her own review of it, and then a YouTuber by the channel name It's BS did a presentation on it, and you could check that video out if you want to get a full extended version. This is kind of a broad overview. So let's take this equation here, E equals hv. What you notice here is this describes energy being equivalent, to the frequency of the wave, essentially. Times Planck's constant, but there's no time variable. So what does that mean? That the time of the wave is subject to its speed. So the physical existence of the photon is directly proportional to the existence of the wavelength of the photon, right? So if you take a photon of 3 hertz or at a 3 hertz frequency that exists for 1 second, that photon would be 300 million meters long because of how the speed of how it's derived, how by default it would be derived from the speed of light. So I'll go ahead and read off what all this means real quick, and then we'll end on that. All these are wave equations. The physicality of the photon that is required of it to propagate through a vacuum only exists in your imagination. If the conceptual mathematic extrapolation of the physicality and behavior of the photon existed as described by the wave equations, then the photon would be directly proportional to the wavelength of its existence. The speed of light is set by c, 200 million or 299,792,858 meters per second. This means the photon that exists at a frequency of 3 hertz for 1 second would be 300 million meters conceptually. Obviously, there's no 300 million meter long photon. Oops. That would be like saying that the physical size of that 3 hertz photon would be nearly the length of the distance from the moon to the Earth, assuming heliocentric mythology, placing the moon at approximately 384 million meters away. And so that's the death of the photon. So when you look at atmospheric conditions like this, for example, what's not happening is that there's not a bunch of, well, okay, so there are a bunch of air and vapor molecules, right? But there's no photons that are that just happen to be, um, millions and millions, quadrillions and an infinite amount of photons, essentially, um, traveling through this medium, and they just so happen to um, hit the molecule and deflect at an angle, all coming out in just a way that produces a perfect visual horizon, in every direction. Everywhere you look, everything is all evenly distributed out. You can see the horizon with no photon loss. Like, there's no patches of lost information where the photon isn't reaching your eye because the light, hit water molecules and it didn't bounce in a direction that raised the horizon up to where it could meet your eye. So you have like this visual loss in the horizon. You always see, um, like the same thing in the distance, right? Now this movement of the horizon, right? Now this is due to the medium itself, right? This is due to the atmospheric conditions itself creating an actual lens, right? So the land and everything back here isn't moving. Photons aren't being lifted up and redirected around through molecules. There's literally just a lens here in between the observer and the distance, and the conditions of the lens, the atmospheric conditions, are compressed at the horizon, from the top and the bottom. So all the conditions that happen in between, the temperature differentials and all that stuff, this is all lens effect, not photon traveling through a lens effect. I hope that adds some clarification to how illumination works and how there's no photons, and how the idea that a photon propagates through a vacuum of space without being a physical thing that has mass to have momentum, is just a fairy tale, and it's a mathematical reification fallacy. All right, and that was a short segment from my presentation, How Math Became Reality. If you'd like to follow up on that and find out why they felt it necessary to come up with a reason to explain how a wave could propagate through a vacuum, check out the rest of my presentation where I go into great detail on the subject of general and special relativity, and and you could learn the history of why they came up with these equations, and what it means for physics and cosmology. Thanks for your time, and share this video if you like it.